My name is Ron Shapiro. I'm the Vice President and CTO at Qvera, and I'm here to give a brief overview of the Qvera FHIR Starter Kit. And that's the end of my presentation, because we're going to get right in and look at the actual code. The Qvera FHIR Starter Kit is a free download. It's available at Qvera.com. And if you go there, there's a short YouTube video that walks you through how to install it and how to use it. There's two components to the FHIR Starter Kit, and I'm going to try and go over both of those in this short presentation. We've got the FHIR Starter Kit and then the CDA to FHIR demo. Each of these run inside of the Qvera interface engine, and so I've got the Qvera interface engine in. When you get the FHIR Starter Kit, it includes two channels, one that is the demo web page, and then another channel that actually does the work, the FHIR server. It mocks up a FHIR server. And so if we load up the demo web page, it brings you to a screen like this. You'll notice that same YouTube video is right on that demo web page. And basically what we have here is the ability to introduce someone to what FHIR is and how you can use FHIR in healthcare. And in this case, we're going to retrieve some pre-canned resources that we have here. We can get a patient, an appointment, or an immunization. And then we're going to retrieve that either as JSON or XML. And then we're going to transform it into an HL7 version 2 message. So for a patient, it'll become an ADT message. For an appointment, it'll become an SIU. And for an immunization, it'll become a VXU. And we'll extract out all of the data we need to create those HL7 messages. So we can hit our own FHIR server running locally, or we can actually go out and hit, say, the Happy server or Graham's test server. And so if I go to the Happy server and I look for anybody with a family name of Doe, it'll bring back all the John and Jane Does. It found 93 of them. It brought back the first 20, and it brought them back in JSON format. We could switch to XML, and then now it's in XML format, 93 of them. But it brought back, the Happy server only brings back 20 at a time. And here are the 20 ADT messages from each of those messages. So let's look a little bit about how that happened. If we come back into the integration engine and come to the web page, we can bring up that last request and run it in a test scenario and step through. So the request came in, posted to the FHIR demo web page, asking for patients from the Happy server. And so it parses the request, queries the Happy server. Here's where it queried it, and got the 93 results. And I wanted to step you down through where it converted it to HL7 messages. So here's our 93 Jane and John Does that we retrieved from the Happy server. And then these are patients. And so in that case, we're going to create HL7 version 2 ADT messages. And so we convert from the XML to the ADT messages. And we can come in here and show you that we parsed the XML response that we got back from the Happy server. We got all of the patients' resources that we found in there and then iterated through each of those, pulled out an HL7 MSH template, and then we built the PID segment into that HL7 message. The Qvera FHIR Starter Kit comes fully documented so that someone can easily digest and find out how each of these things are happening and go ahead and modify it and learn and grow from there. Let me see, was there anything else I was going to show? So then you've got the offline mode where you can grab an immunization. It gives you some samples of data to use to search for those, whether it's the lot number. You can submit the query. It shows you the format, similar to if you're using Postman that you would use to make that query. And so then here's grabbing an immunization and creating a VXU message. The interface engine manages all of the REST web service calls and manipulations of the messages. It's very powerful in that regard. So let's switch over for the last couple minutes to the CDA to FHIR. Similar to the Qvera FHIR Starter Kit, the CDA to FHIR also includes two channels. One channel that manages the user interface, and then the actual channel that converts a CDA document into a FHIR bundle. So if we load that up here, you can paste in your own CDA document, or you can choose one of these pre-canned ones that we have. So I'll pick Gary's CDA. And you can see here that we have a clinical summary, and for Gary fake mail, we can choose whether we want the resulting FHIR bundle in XML or JSON, and then we can call the convert CDA. In this case, it's now converted this large CDA document into a bundle of FHIR resources. And so if we look for Gary fake mail, then we can find the patient resource, and as a FHIR bundle. So let's find out how valid this is. We can post this FHIR bundle to any of these servers, and it will return a result on whether the FHIR bundle validates or not. So we'll go ahead and use the wildfire server. Validate the bundle. I'm trying to scroll up. So here's the operation outcome of that validate operation that we just ran against the wildfire server, passing that bundle of resources. Now Gary's CCD is a very large one, and that's why it took a minute to convert it to FHIR. And we can also just extract out the div from the validation engine and see what our validation errors are. So in this one, it's saying that for the effective period on one of the resources, if we have a start, it needs to have a lower value than end. So just to dive in a little bit real quickly on how that FHIR bundle was created, if we step in here and we grab this and step through it, we can see that we extracted the CDA. So if I step one more. So here's the clinical document that's extracted out. And then we begin to build this FHIR bundle, a component at a time. So we add the bundle, we add the composition, we add the practitioner, we add the patient. If we drop down to the bottom here, we can now see that the patient was created. And just to give you an idea of how that patient is created in code, I'll bring up that mapping function. And so this is the code that builds the patient JSON resource out of that CDA document. And then you can then easily, in the integration engine, translate from JSON to XML with one line of code, and it turns that FHIR bundle from JSON into XML. And I believe I am out of time. I have so much more to show, but I will turn it over to Eko.
All right, thank you. All right, hi everyone. My name is Eko Prasetya. I work at Carium. It's an early stage startup. So what we build is a patient healthcare management system. And one of the things that we built is, and I'm going to talk today about the CareDB, one of our, the engine that actually manages the patient data. It's a SQL-based, database system where we have FHIR API, and we have a CLI that actually manage that actually make it simpler for us to develop stuff. It's based on a SQL database, and also allows us to import data from many different sources. Now, one of the issues that we found so far is that when you start managing data from multiple different sources, then you start seeing things like, okay, how do you plan to merge the data, and how do you plan to distribute the data, and how do you plan to merge them together? And then we realized that if you guys are familiar with Git version control, Git are really good at it, right? I mean, if you look at the way the data is being managed today with Git, you can have many different developers managing their data. You can actually branch it out, you can clone it, you can modify it, and you can merge them together. So we thought, like, okay, why don't we actually combine those technology between the SQL database that we have, and also combine it with the Git technology, and then we come up with something, different, right? So, as the fundamentals of what we build is like, we have a SQL-based database that can support multiple sources. We can commit at any given time so that you can actually see how your data actually looks like at any given time. You can always move backward. You can move forward to see where your data at any time. You can distribute them. You can clone them. You can merge them. And we have a FHIR API on top of it. And we're still cleaning up the repository. Again, our company is still pretty young, so we still have some work to do. But we're considering moving this to open source. So if you guys are interested on it, please let me know. Now, that should be the only slide. The rest is just want to demo you with something. So in here, I want to show a very simple. Sorry. Yeah, in here I have one simple patient. You guys are familiar with MySQL. So it's built on top of Django. So basically any database that Django supports, it should be supported with this one as well. So you can, in here I'm using MySQL, but in our production, for example, we're using AWS Aurora, but we have tested it with Postgres, Oracle, DB2, you can use that one too. So in here I have a simple patient object, empty, nothing. So, and if I look at, so I have a simple, CLI comment that to see this is the current status of the data. So I can also see the status. Right now, we're working on the master branch of the data, okay? And if I do see git log, again, if you're using Git version control, you're probably familiar with all this. You can see I have 2 commits so far. I have an initial commit and I have initial patients. So what I'm going to do next is, I'm going to upload a CCDA for this patient. I have a sample synthetic CCDA data. It's going to take some time. So what it does is really take the data from that patient, load it into our database, and I'm pretty sure you guys know about that one already, so I didn't want to go too far from it. But now you can see that now on the core patient we have this one, so we can also see that so on the medication statement for this patient, we have about 9 records, right? So what's interesting is like, when I did that CCDA upload, what I did was actually taking the CCDA, go to our care database. Now, so what happened is before the import happened, I created a branch, I call it import user, but we can have as many branches as you want, just like in Git, you can have as many branches as you want. And then I create that branch, import the data on that branch, and then afterwards I will merge it to the master branch, right? So if you look at the log now, you can see that now we have, initial commit, initial patient, but now I have one other commit called importing from the import user. Also, what is interesting about this, now we can actually see now we have 2 branches, right? One is master and one is import user. So, and I think that's still okay. But the next one that is more complicated is like, now what happens, like after I import, sometimes I feel like, since I'm a patient, I own the data, now I want to start changing something locally that is outside the CCDA import I did, right? So this is on the database. What I want to do, I want to do an update. Let's say this patient got married, right? So I want to update the marital status to, let's say, what, M, right? And the name, so this one is it's a JSON structure, so. Sorry. So I want to change the family name. Maybe after she got married, maybe her family name changed to Wayne, let's say. Okay? So if I do this, you can see that now the marital status is M, and the family name is Wayne. Now, if I do secret status now, so what happened is it will take a look at the current state of the database right now and see what have changed so far. Since I did not change anything on the medication side, nothing is shown there, but you can see that the patient was changed. Now, what has been changed from the last time I committed? I can actually do this. You can see that the family name was changed from was that Moreno to Wayne, and the marital status was changed from single to married. Okay? Now, what I'm going to do next is, now I want to upload another CCDA data, in which it's very similar to the previous one, except that now this one actually has one additional medication statement. Everything else is the same, okay? So I have this. This is the second one. So now, so if I do a secret status right now, again, everything is clean because we already commit everything. And you can, if you look at the log, you can see this is the previous import. We do a pre-merge commit, so we commit everything before we import anything. And then we import the new user, and then we merge it with the master. Now, the interesting thing about this is that, so on the core patient, since we changed the last name on the master branch, and so instead of blindly copying the data from the CCDA import, we actually check the differences based on the common root on the tree, right? Since the last time we import the CCDA data, we know that the marital status and the family name did not change from the CCDA import. We did not merge that one, right? So the only thing that we changed was only the medication statement. So that's why if you look at the current patient right now, we keep the changes on the master. Now, well, another interesting thing about this also is that because we have everything in the log, so one day you probably want to say, okay, what was happening, when the data was on the previous commit? You can actually do a checkout, just like in Git. And you can see this is the data of the patient at that given time, right? And if you can see, the core medication statement was 0 because there was no data at that point. But you can also see what happened when the data was initially imported, not the second one, but the first one. So you can check it out. You can see this is where the family name was still Moreno, right? And then you can always do a checkout to master to see the latest one in the tip. This is the last one when the family name was changed. And not only that, we can also check out on the branch as well. See that we actually have a master and import user, and you want to know exactly how the data looks like when you import it without being tainted by anything else. So you can always do a checkout based on the branch. So this will show, well, this one will show Moreno because this is how the data look like when you import from CCDA without being merged with anything. Now with this information, you can actually have multiple branches and you can see how the data look like on many different sources. Okay, I guess that I'm running out of time, but thank you. So if you have any questions or anything, let me know, and we're hiring, so thank you.
Okay, so I'm going to show you two tools that I write for myself, and because they're mostly just repackaging the tooling from the reference implementations or the servers, it's pretty easy for me to make them available. So if you go to my website which is healthintersections.com.au/FHIR server. You'll see that I released some tools. I'm going to very quickly show you two tools, the FHIR Toolkit and the Notepad++ plugin. The FHIR Toolkit runs on both Windows and OS X. At least it theoretically runs on OS X, but I'm having trouble with SSL on OS X right now. And the Notepad++ plugin is an actual extension to Notepad++ that only runs on Windows, well, or any system that runs Notepad++, which is a Windows program. So these are tools that are aimed at developers. Pure developer-focused tooling, that's what they're for. So Notepad++ plugin, if you open, when it's installed, if you open, I don't know what these things are, but if you open a resource, either JSON or XML, then it'll come up and say this is valid against which versions of FHIR it's structurally valid against. You can validate that, although I tried it a few minutes ago and I'm offline, so it's erroring hitting the server. And you can see the narrative of the resource. You can change the format to XML if you want, or back. You can play around with FHIR path. It's a FHIR path statement that hopefully will work. It shows you that patient.name.family selects this family element in JSON. Or you can pick an element and say, what's the FHIR path to get to that element? So that's the FHIR path there. You can create new resources in any version, and basically it'll go through the profile and populate the new resources with a bunch of not very useful data based on the profile, any fixed values in the profile, or you can connect to a server. And of course this won't work if I'm offline, and pick resources off the server directly and just open them in Notepad and push them back up to the server. A bunch of other stuff that I found useful, code generation. So anyone's welcome to download that and give it a go. The other tool is the FHIR Toolkit. So FHIR Toolkit is a slightly different tool. Instead of editing the resources in JSON or XML, it loads them and lets you edit them directly. So I've put a bunch of useful things in here because I do a lot of editing value sets and code systems and questionnaires and so forth as part of maintaining the spec. And I get pretty bored of doing them in XML or JSON. And so you can create new resources. Currently I support capability statement and value set and code system and questionnaire. I'm not going to do structure definition because Michelle's going to show you Forge shortly. And then once you've opened a code system, you can say, well, I'll fill out all the details that go with the code system, and I'll start defining concepts. And you can look at them either as a tree of nested concepts or so forth. The questionnaire editor, I've put quite a bit of work into, so you can see this is one of the questionnaires out of the examples in the spec. You can see these are the questions that are part of the questionnaire, or you can look at them in a sort of a semi-layout thing and move the questions around. I'll move that one up or back down. And then you can edit a whole lot of properties of each of the questions in the questionnaire. For those of you who haven't looked at questionnaire, it's a really powerful tool, but tooling is not really there. So as far as I know, this is the best questionnaire editor that's out there for playing with. Alternatively, you can connect to a server. Probably this will fail. I know it's back online. And search for patients on the server or conformance and terminology resources. So we'll search for value sets associated with account, and then you can open the value set. If you have a resource and you've edited it, so we'll edit something, you can see the source as it currently is in either XML or JSON, or if you're really strange in turtle format. You can see the original, and you can actually check the differences as a patch for the patches you've made to the resource. And you can also validate, but that's something I'm still working on getting it right. That's probably all I wanted to show. I'm using my time. The tools, the tools are maintained as a hobby for me. They're not like bulletproof the way Forge is. Well, it's perfect, Michelle. Come on, it's perfect. But everybody's welcome to download them, test, use them in anger, because they're not end user tools, they're developer tools. So if they break, you can tell me about it, and I'll fix them. Hopefully, you can all find something useful in your development process with those. In particular, if you're you have to end up editing capability statements, which everybody has to have one, all the servers have to have one, then you can. That's one of the best ways to edit it. So thank you very much. And now it's Michelle's turn. Okay, I can add some download instructions. Windows is easy. You click and then you install. OS X is harder.
Mooi. That worked fast. So I'm going to show you Forge. Forge is a profile editor. You can download it for free from Simplifier. So if you go to simplifier.net, you can see the button here. And this is where you can download Forge. It's not open source, but it's freeware. So just create an account in Simplifier. It's free and you can download it. Start it up. So it's a Windows desktop application. You can run it on Apple or Linux using Wine. So if you install the Wine platform, we tried it out and it works. We disable hardware rendering and it just goes okay. Or alternatively, you could use a virtual machine, but it's kind of, you need a Windows license. I'm not about to port it to Linux or Apple. That would take a little bit too much time. So you can see, you create a new profile, and what it does out of the box, Forge comes with a zip file. That's the official zip file that contains all the definitions of the resources and the data types, so you don't have to load that. You just download the version of Forge for the right FHIR version. We have separate versions for DSU2, SU3, and within a couple of months, when R4 goes final and is stable, then we'll update Forge and bring a separate release 4 version of the tool. You can install them side by side on the same machine, so you can work on old DSU2 profiles, but also on new SU3 or in the future release 4 profiles. But the tool is hard-coded to a specific FHIR version, and these resources are baked into the tool. So I can, for example, create a patient example. You can see the tool shows you, let's enlarge that a little bit. See the working group that's responsible. It's a patient administration, it's maturity level 5. And it's actually drawn from the definition, so that's not hard baked into the tool, it just reads the XML. Generates a canonical URL, and then we can start profiling. Now it loads that XML, it loads the structure definition and builds up the profile for you, and you can add adding constraints. For example, usually we don't work on animals. I'm not a vet, so I'm going to strike this, and now the animal is forbidden. And the tool tries to help you by indicating these constraints with a yellow pen. So when you open up a profile created with somebody else, the tool will show you which elements have been constrained and which elements are default and out of the box. So it's kind of helpful. It's really painful to write these XMLs by hand, especially when they become larger and you use slicing, and then you really need the tool. Even I can't do it by hand. It's hard. So we need tools. One of the things I want to show you here is what Forge does is when you open a profile, it actually scans the whole folder and all subfolders. And that's not really clear in the user interface right now. It looks like a single file. I'm opening up a profile, but actually I'm scanning for extensions and related profiles because maybe your profile will walk onto the other profiles and I need to find them. So I scan the whole folder. And because it's not really clear, what people sometimes do nowadays, they save a profile to the root of the disk or to my documents. And then the tool happily starts scanning the whole hard drive, and it takes 45 minutes, and people start complaining, why is Ford scanning my music folder? I got actually these responses from people. So I've been working on a new version with an updated user interface. You can't download it yet, it's still under development. And as you can see, I changed the flow to kind of more make it clear how the tool is working. And I've looked at Visual Studio, where you just open up a project. You open up a project folder, or maybe a web folder or something, and you can get all the files in the folder. You understand that the IDE is actually scanning that whole folder. So now, I've downloaded a project from a Dutch standards organization, NICTIS. They created a whole set of profiles on GitHub. I just pulled that repository, and now I can open that folder in Forge, and you can see I have a checkbox. Say, scan the subdirectories. You have to actually enable that. I will remember the setting for you. But now when you open up My Documents, it won't by default run into the whole hard drive. So you know what you're doing. So select a folder. Now it starts scanning the resource. You can see it's very fast. We've been working on an API on a scanner that it doesn't try to parse the whole resource, but it walks into the metadata, sniffs a couple of elements, and then stops. So it's even able to display corrupted resources or DSQ2 resources incompatible. It will show you. But it will try to sniff out the canonical URL and the title, everything it recognizes. And because I don't, especially stuff like bundles, classically we would deserialize the whole bundle and then get the ID and throw the rest away. And we would allocate 50 megabytes of memory and be crunching the CPU, all for nothing. Now we don't do that anymore. We just hit the bundle ID and stop. So it's much faster. And it's kind of safe to open a folder with 1,000 profiles or something, because it's not all actually deserialized. And then from here, well, this is a flat view, or you can go to a folder view and just walk in the folders. Maybe let's look at the patient example. And you don't just see the file name, just like Graham's tool. You can see a part of the metadata, like the canonical URL. This is a profile on patient, and we can open it from here. And, well, this is because I'm walking to extensions I haven't downloaded yet, so that's package management, a different discussion. But now I open the profile, and now you get the same user interface that I just demonstrated. And you can see the little pen with the constraints. So when you're working with the current version, when you download Forge, just be aware it scans the whole folder. So put all your data type profiles, your extensions, just from the folder. You might create subfolders, but don't save your profiles to the root when you use this tool, because it will scan the whole hard drive. And this new release, I'll be completing this in the summer and hopefully release that for the next WGM. Thank you. There you go. Oh, maybe you should.
Oh, you were loud and clear, I think. Good morning. Good morning. My name is Marco Visser. I'm a colleague of Michel. I work at the FHIR lead team. And today we have a nice thing to announce, because we released last week the Func-loader. With this tool, you are able to load large sets of resources to any FHIR server, not only the Func FHIR server, because we call it Func-loader, but any FHIR server you want. We developed this tool several months ago, I think more than a year maybe, and for our own server, for loading large sets of data and to measure some performance testing for our Func server. But we noticed that some other clients and in the community, that there was a demand for this kind of tool. And so we decided to make it public. So we did that last week. It's a command line tool. It works on Windows, Linux, and macOS. And it's uploading the resources in a parallel fashion. How do we install it? First, you have to install the .NET Core 2.1 SDK. You can download it of course, at Microsoft. And then just open the prompt and just fill in .NET tool install global -G and Func-loader. That will, you see here what I did yesterday. You get this, hopefully you get this green and it's successfully installed. And then you can run the Func Func-loader with -h for kind of helping the parameters. What are the parameters? The available parameters are here. It's not so much. I think it's 5. 1, 2, 3. Yeah. First one is the file. The file is a zip file containing all the resources in it. That can be XML or JSON files altogether. Doesn't matter. You define the server, where it goes to. You limit it if you want to. So you can limit it. I want just the first 2 resources uploaded, or all of them if you leave this limit parameter away. The parallel, how many sessions you want to upload it. So many requests in parallel. Default is -10. Default is 10. And some collection handling. Sometimes the resource is a bundle, and you can say, well, let's split the bundle in separate resources and send them one by one to the server. And then a parameter allow create. Well, if it has no ID, it will create the ID for you. So I had already the mark at 4 minutes, so quick demo. It's here. I already have this PowerShell. I already downloaded it. So if you go to Func-loader, you don't even have to have the -h. You will see the usage of it. I have already a zip file in my download directory. That is from the specs, all the examples in it. Just, well, you know this, I think. Here's just one example. This is an account with an ID HWG. And I want to upload that to the server, so just type it in. Do you know what? I already have it. That's easier. I sent it to the FHIR server at this moment, and I said I want to limit it at 10. So now you have the first 10 resources uploaded to the FHIR server, and I think it was 10 in parallel. Yeah, defaulting to 10. And that's it. So it helps us quite a lot with our work, hopefully also with you. If you want to have more information, then you find here the links. You can contact me if you want. I'm upstairs at the hands-on table as well, so you can find me there if you want some support with that. All right? So that was it. Thank you much for your attention, and happy coding.